Today in this video, we're continuing the topic of the mathematics of finance, and we're going to be looking today at credit cards. Specifically, what we're doing is calculating the finance charges of credit cards and consumer loans. With the consumer loans, we're going to be looking at two aspects. What the monthly payment would be, and this would be like buying a car or something, and then if you're going to pay it off early, if you have the funds to pay it off because you want to be done with it, how much would you have to come up with to pay? So those are going to be the two things we'll be looking at when it comes to the consumer loans. We're going to have a bunch of vocabulary though to cover. First of all is the idea of just what a credit card is. A credit card and a debit card are not the same thing. A debit card draws funds directly from either a checking or a savings account. But a credit card is a line of credit, which what that means is it's a pre-approved loan. So when you use your credit card, when you swipe that thing to buy something, you're actually taking out a loan. At that point, you've just created debt because you've taken out a loan. The finance charge is the amount paid in excess of the cash price. In other words, this is how much the thing you're buying costs. But then for using that loan, you'll end up sometimes, and I'll explain what I mean by that in a second, sometimes paying what's called a finance charge. And there's actually two kinds of charges you have to watch out for: finance charges and late payment charges. Late payment charges we're not going to calculate today because most of the time they're just laid right out when you sign up for your credit card. If you pay your card in full, what that means is, let's say that you have bought something for $150, and as long as you pay that $150 by the due date, most cards do not charge you a finance charge. There are a few, especially for first-time credit card users. Sometimes they'll charge you anyways. But most of the time, as you get older and have built up a credit score, you can get better cards. And there's a lot of aspects of what I mean by better. And I'm not going to get into all that right now, but you can get better cards that only charge you finance charges when you have not paid in full. Okay, so that's the second part here. But if you're late or do not pay in full, then you're going to pay a finance charge. And the late actually is a separate thing. It's all called the finance charge, but this is actually different than paying the interest. Some people say, well, why don't you just call it the interest? Well, because it could be talking about the late part as well. So take that $150. Let's say you only paid off $100 or paid $100 on your bill, and then you let that $50 ride for a month. Well, then you're going to pay a finance charge on that $50. But you're also going to pay finance charges normally with most cards on anything else that you buy during that month and put onto that card. And so we're going to be looking at that. For some credit cards, the interest charges start to accrue on a daily basis from the due date. Not only on remaining balances, but like I said, most cards actually start to charge you based off any new charges. Not all of them. You kind of have to know what you're getting into with each card. Visa, MasterCard, Discover Card, all those different kinds of cards. And again, even those companies, they have different levels of their cards. For people with better credit scores, they're offered cards that have fewer charges in a way. It's you have to like read the details about each kind of card. But that's for something for you to actually sort of experience as you get older. But we're going to be looking at calculating those charges, that finance charge. The way that we're going to do this, most, again, cards do it this way, but not all. Most of them use what's called the average daily balance method. Okay, so what we're going to do is, first we have to come up with what was the daily balance. The average daily balance is a common accounting method where credit card interest charges are calculated using a total amount due on that card at the end of each day. So we actually have to come up with how much was on the card for every day of the month and add it all together, which gets to be a really big number, and it kind of feels like you're doing this wrong at the time because it's like, wow, that number is huge. But then we divide by the total number of days in the billing cycle. Now this next part kind of makes me giggle a little bit, But this seems to be the most problematic part I've noticed with students doing this is they dividing by the total number of days in the billing cycle because of how many juniors and seniors in high school don't know how many days are in a month. So you might have to review that. There's 30-month days, there's 31-month days, and then of course there's February, which is either 28 or 29, depending on whether it's a leap year. If you don't know, pull out your phone, look at the calendar, and see how many days are in that month. Okay? So, like I say, that just kind of makes me giggle as a teacher because this seems to be the thing that students find the hardest out of the whole deal, is just knowing how many days are in a month. All right, so let's take a look at doing this. The average daily balance method. We're going to use that to then calculate the simple interest formula and apply it to that balance. When we're all done here, the finance charge is just going to be the simple interest formula. Interest equals principal times rate times time. And in fact, it's even easier doing this because the time is just 1 month. So we're just going to use a 1, which means we can sort of even ignore it. The hard part, the part that takes effort, is figuring out this average daily balance. So you have to add up how much was in the account every day of the month, which means if you bought or sold things, that amount's going to change. And then of course divide by the number of days in that month. Now, a lot of times your monthly cycle for the credit card goes from the day that you signed up for the card, so it changes. For one card, you might have it go from like the 15th to the 15th. But another one, you might have it go from like the 22nd to the 22nd. And it doesn't seem to have any rhyme or reason unless you remember that it's usually the day that you signed up for the card starts the billing cycle for your particular card. Okay, so keep that in mind. I like to use this chart. It doesn't mean you have to use this chart, but this is what I tend to do. Now let me explain what you're looking at here. This one that I'm going through, it goes from the 15th to the 15th. Okay, so 15th of November would be the first day of a new billing cycle. And this chart tells me that they had $325 that remained on their credit card that they didn't have paid off. Okay? Then on the 20th, so 5 days later, they bought something. I know it's a purchase because it's a positive number. It's a plus. So they bought something for $65. Then on the 25th, again, 5 days later, they paid on their credit card because the minus here tells me, oh, they're paying on their credit card. And so that's going to change things. All I did from here to here is this one, I added the 65 to get a new number. Here I'm going to subtract 200, gives me that number. And then from the 25th to the 28th is 3 days. Then they went and bought something again. And so that number is going to get, it's again a positive, so that number is going to get bigger. Okay, so I first figure out what are the different amounts during the month. Then I figure out, well, how many days did it sit at that amount? Okay, so like here, from the November 15th to the 20th, well, that was 5 days that it sat right here. Remember, we have to add up the total for every day. That's what the first top part is, the total for every day. So I'm just going to, I mean, I could go 325 plus 325 plus 325, but I'm just going to multiply. So I multiply across, and that gives me the total for those 5 days. And I just continue doing the same thing. Again, you got to watch the dates. There was another 5-day period. It sat from here, it sat at this amount for 5 more days, from the 20th to the 25th. Then it changed. So 5 days at the 390. Then it sat here 3 days. Notice I'm always calculating ahead to see how many days it was. And so it sat from the 25th to 28th for 3 days. So at this amount, it sat there for 3 days. So I multiply to get that. And then you might be wondering, well, how do I come up with 17? Well, it's going from the 15th to the 15th. So we're going from the 15th of November to the 15th of December. Okay, so from the 28th of November until the 15th of December, that's where I'm coming up with my 17 days. So for 17 days, it sat at this amount right here. So I multiply, I get that. Then I just add all of this stuff together to get my total, which is the top part of this fraction right there. Okay, so that's the part that I put right up here. Then I'm going to divide by the number of days, which of course because November has 30 days, it's 30 days from November 15th till December 15th. You really got to put a little thought into this though. If I were looking at the next month, if this had been December, because December has 31 days, then I'd be dividing by 31. So I divided in this case by 30 days because there's 30 days in November, which gives me, there's my average daily balance. Like I said, this is the hardest part. This is what I'm going to use for the principal when I go interest equals principal times rate times time. That's the number I will use. And then from that, I can calculate my finance charge. That's the interest part. Okay, so here's those numbers again. Like I said, once we get this, then it's just a matter of calculating the interest, which is going to be the 406.77 times 15, oh, excuse me, not 15, 1.5% or 0.015. So these monthly charges, I want to make a comment here. They really don't sound bad. Say, hey, 1.5%, hey, that sounds pretty good. But because they're doing this monthly, not annually, which is why it makes the calculation easy, because we get away with just putting a 1 here because they're doing it monthly. But if you were to multiply this times 12, that's 18% interest in a year. Credit card interest is not cheap interest. It tends to run about 3 to 4 times higher than you would get through a bank if you were to go and apply for a loan. It's a lot steeper rate. I'm not saying that you shouldn't have a credit card. For convenience and for emergencies, and that's what I recommend students think of them as, for emergencies. For emergencies, they're really handy to have. There's a lot of situations where you almost need a credit card. But you need to be responsible with the credit card and know that if you start paying these finance charges, you're going to be paying about 18 to 22% a year, depending on your credit score. Well, this will change based off your credit score. So in this case, though, for the month, the interest they'll pay on for the month is going to be $6.10. So that's what you'd be paying for the month, which again, if you're like, well, that doesn't sound so bad. Well, if you look at it from a yearly aspect, though, you take that $6.10 for the year, you'd be paying $73 of interest on a $400, basically a $400 loan. You're coming up on a quarter, you're coming up on 25%. You know, it's only 18, but it's approaching it. It's actually a very big number that you pay for interest for finance charges on your credit card. All right, so there's how I calculate it. Now I'm going to make a comment. I use this little chart. I just scratch it out on a piece of paper. I've had a lot of students though that don't do it this way. I have had some students literally list off every single day and then add them all up because the chart confuses them, in which case that's fine, it'll work. All you have to do is come up with what the amount was for every day, add them all together, and divide by the number of days. If you like the chart, make a little chart. If you don't like the chart, then make a list. I've seen students that just actually do this on their calculator as well. They just in their head, they figure out the days and the amounts. Well, they figure out the amounts first, and then they just go 325 times 5 plus 390 times 5 plus 190 times 3 plus 474 times 17. They hit enter, divide by the 30, and they get the same thing. So however it works for you, put some thought into how you want to approach a problem like this. You might want to do it a little differently than me. So I'd like you to try one here. This is going to go from the 12th to the 12th. Again, these dates are kind of weird and random because they're based off of normally when you opened the card. And I am throwing a February at you here. Let's assume 28 days in February. Okay. Suppose that they started out with $405 on their credit card. That starts out on the 12th of January. Excuse me. We're going to be using January, not February. We're starting in January. So 31 days. A purchase of $45 was made on the 18th. A payment, so this is going to reduce the amount. A payment of $200 was made on the 25th. A purchase, so it's going to increase, of $60 was made on the 3rd. And then the end of the cycle is on February 12th. Same interest, 1.5%. That's kind of a standard interest rate. If you want to make the chart, make a chart. If you want to make a list, make a list. However you want to do it, I'd like you to pause and try it. All right, so I made the chart. Here's my chart starting on the January 12th, 405 until the 18th. That would be 6 days. Bought something for $45, so that went up until the 25th of January. So back here, that was 7 days. On the 25th of January, they paid $200, which dropped it down to $250, and it sat there till the 3rd of February, which meant that would have sat there for 9 days. And then on the 3rd of February, they bought something for $60, which increased that amount, and it sat there until the 12th of February, which would have been another 9 days. I multiplied across, added down, and divided by 31 because there's 31 days in January. So now I have my average daily balance. Maybe pause and see if you matched up with that because the rest is pretty simple. Then you just use the interest as principal times rate. I don't even have to put the time because it's just a 1 month. And so I get $5.14 of interest or finance charged in that particular month. Okay, so that is the calculations for credit cards. We're going to kind of switch gears here and talk about consumer loans. In a consumer loan, what we're going to be looking at is two different things. A payment amount. So let's say you're buying a car or buying furniture, some big ticket amount. This is going to be different than a mortgage. Consumer loans are not the same thing as buying a house. A mortgage is a legal document. It's way more complicated than just buying a car or buying a house, way more complicated. But for this, we're going to be just looking at calculating out the payment on some consumer loan. And as you can see, it's a very, very large formula. You're going to want to put this in your notes and write down what the parts are. I'm not asking you to memorize this. I'll never ask you to memorize that. That's a monster. What the parts are. A is going to be the amount of the loan. The R is the annual interest rate, okay, whatever you're getting from the bank. And this would be from a bank. Or it could be maybe like from the furniture store or the car dealership. They will give you consumer loans as well because they're usually working with a bank. The N is the number of payments each year. So this would be like the quarterly is 4, semi-annually is twice, things like that. T is the number of years of the loan. Notice there's a negative in this exponent. That's not a typo. That is a negative right there. It's kind of a different formula. And you're going to see a version of this now several times over between the end of this video and the next one that I go through. So let me do an example here. A person is agreed on, they looked at a car and they agreed on with the salesman at a price of $10,500. Now you might think that, oh, that's my amount right there. Cars are more complicated though. Well, and most anything's more complicated because that's not the amount of the loan. A lot of times you're going to pay tax. Okay, and I'm in Minnesota here. You're in Minnesota. So Minnesota tax is 6.875%. So that's probably going to get put into the loan. There's also in Minnesota and in most states what's called a title and transfer fee. Well, most people throw that into the loan as well. So $46.25. But a lot of times people have money to put a down payment. In fact, most banks will require a down payment. And in this case, the down payment is going to be $2,000. So that would reduce the amount of the loan. So I have to take the sales price or the ticket price. I got to put in my tax, put in my title transfer fee, reduce it by any down payment, and then I finally have the amount. So there's actually quite a bit you got to do before you even start this formula. And then once you start the formula, I will warn you that the issue is going to be getting it through your calculator without making a mess of it. I'm going to calculate out within what the payment's going to be For an interest rate, so this is going to be the R, 7.75%. That's pretty much standard. It's not a great rate, but that would be like somebody without a great credit score. With a decent score, you can get usually in the 5 or 6% range. And let's say it's a 4-year. And most car payments are monthly, so the N here is going to be a 12. All right, I want to know how much will the monthly payment be? That's just usually what people are interested in. Can I afford to make whatever the monthly payment is? So again, the first job is to figure out the amount of the loan. And I kind of wrote it like a formula here. It's the price, take away the down payment, add in the tax. The order here doesn't really matter, but at some point you're going to put in the tax, take away the down payment, add in the title transfer. You don't get taxed on the title transfer fee because it is a tax. As they say, fee, F-E-E, is a different way of spelling T-A-X. Okay, so it's basically its own tax, so you're not getting taxed on the tax. Why don't you try this on your own? Pause it and give it a try. I am going to work through it, but try it on your own. It's good for students to try this. Okay, so here we go. I'll go through it. So the amount of the loan. This is me getting the amount with the tax. I'm using 1.06875. That's that little trick. It's 100% plus the percentage of tax. So that's my way of getting the agreed upon sale price with the tax. Take away the down payment, add the title and transfer fee. And again, the order here really doesn't matter. You gotta be all combined. So I've got then that ended up being $9,268.13. That's the amount of the loan. Then I got my interest rate for my loan divided by 12 times a year, 12 payments in a year, over 1 minus 1 plus the interest rate over 12. Comment here, some students want to cancel these out. You cannot do that. Order of operations here. Because of this or this, either one of these plus or minuses, you cannot just cancel. And then this expression is going to be raised to the negative 48. I'm going to show you the answer here that I got, and then I'm going to give you some advice on running it through your calculator. If you did not get this amount, try this. Start here. Go 0.0775 divided by 12. Then add your 1. Hit enter on your calculator. Raise that to the negative 48. Hit enter. Then get that number and go 1 minus that number. Then kind of set that number aside. Go 0.0775 divided by 12, and then divide it by what you ended up with down here. Hit enter, and then after all that, come out to here. Now, some students I've known are really, really good with their parentheses, and they can do it all working left to right, but most of the time, on a graphing calculator, you'll have more success working kind of from the inside out. And on a phone calculator, oh my word, it's a horrible situation to try and do this on a phone. Definitely go from the inside out. If you try and go from left to right, unless they're making phones smarter than they were last year, it just doesn't work very well. But this is the number. Play with it until you can get it and figure out your calculator, figure out your machine so you know how to do this. If you need to pause again, keep playing with it until you figure it out. Okay, switching gears a little bit. Now you're at the end of the loan. Some people just continue to pay those monthly payments until it's done. But some people, after maybe a period of time, will say, hey, I have the money to pay off this loan. I'm sick of making a monthly payment. I want to pay it off early. That's what this formula is used for. Another kind of monster formula. The PMT is the payment amount that you're going to be paying every month. That's the amount you're paying every month. This is what we're trying to figure out, the loan payoff amount. How much do you got to walk into the bank for? And by the way, because this is based off of days typically, a lot of times the bank will say, well, when are you going to get us a check? If you're going to pay it off early, what's the day that this is going to come in? They'll actually calculate this out to the day. The PMT, though, is the amount paid each month. The R is, of course, the interest rate. There's going to be some commonalities here. R's and N's and T's, they kind of all mean the same thing all the time. N is the number of payments each year. And like I said, in the banking situation, if you're going to pay this off, they might actually do a fractional time unit here because they'll sometimes go to the day. Now here's a new one you haven't seen. U, it's the number of remaining unpaid. That's where the U comes from. Unpaid payments. So if you're paying it off, say 7 months early, well then this would be a 7. It's how many unpaid payments would be left. Okay, and that is a negative exponent. Okay, so let's take a look at a situation here. A person was making a payment of $225.18, so that's going to be right there on a 4-year loan. Okay, so that's going to be the ends. Then, and the interest rate was 7.75. If they are 2 years, 10 months into the loan, but want to pay it off. Okay, so let's just stop and think about this here. You're almost to 3 years. At 3 years, you would have 12 more payments, but you're 2 months shy of 3 years. So that gives you 14 payments still that you would be making until the loan was done. You need to figure that out because that's going to be the U. Okay, so in this case, it's going to be 14 payments. Why don't you pause it and fill in the things, see what you get out of your calculator, and we'll compare here. And kind of the same advice as before, kind of work from the inside out is typically how I advise students to do this, even though I know some students are really good with their parentheses and can manage to actually get it in left to right. All right, so here it is filled in. And again, there's that 14 payments. You're going to have to figure that out every time, how many payments are left. And it should end up being that they need to walk into the bank with a check of $3,004.94. If you didn't get that, play with your machine, play with your calculator until you get it. I would start here, get that number, raise to the negative 14, write that down maybe. Get this number. Then go back and go 1 minus that, divided by that, hit enter a lot, and then finally multiply by 225.18. It's not that students don't usually understand the formula. It's getting it out of your calculator correctly is usually the issue when we do this stuff. All right, there is an assignment in Schoology. It's only a few problems, basically one of each kind, because I know they take time. Like I said, the biggest thing in this whole section is with the credit cards having the method you want to use. You don't have to use my little chart. Do whatever you want. And then with the other two is just getting them out of your calculator without goofing it up. So do a little practice, take a look at the answers. Have a good day.